Hi, so in this recording I'm going to talk about graphs and see how we can easily draw the sine, the cosine and the tangent graphs. So because the sine and the cosine graphs are the easiest, I'm going to start with the sine and the cosine graphs. So let's start with the cosine graph. The sine graph looks like this. And the cosine graph, I'll just draw in a second. And let me just change the color here. So this is one period. Oops, the color did not change. Let me just change it real quick. Okay, so here's the sine graph. So I selected pink. uh, Hope that stands out. And these are the various these lines represent 90 degrees. So after each 90 degrees, as you will see, the sine graph follows a different path. So let's just draw two periods. And the cosine graph looks like this. It starts at 1 and goes down to 0 and then goes up like this, and so on and so forth. But we are just going to look at two periods. So this is 0, this is 90 degrees on the x-axis, this is 180, this is 270, and this is 360. Alternatively, 90 can also be written as pi over 2, 180 as pi, 3 pi over 2, and 2 pi. And this is the amplitude. Let's, for simplicity, keep that as 1 and minus 1. And this is 1 and minus 1. Plus 1, I'm sorry, and this is minus 1. And as you can see, it looks as if the cosine graph is the sine graph moved to the left by this period. It seems as if the cosine graph starts here at this point rather than starting at this point as in the sine graph. So once we know that, let's look at how we could graph this function. Graph any sine or cosine function. So let's do that on a new page and we'll come back to the screen. So let's say that f of x is equal to cosine of x. Now there are a couple of parts that we need to get ourselves familiar with in a cosine graph. So you could have an amplitude 2, then the cosine function x minus let's say pi over 2, and then you could also subtract, let's say, 3 from this function, and you could multiply the x by, let's say, 2. So let's see how that's going to work and look like. So this is cosine 2x minus pi over 3. That is what I meant. So f of x could also be equal to, let's say, 2 cosine 2x minus pi over 2 minus 3. So how will we go about graphing cosine? This part is known as your amplitude. The 2 over here is called the amplitude. By default, that is 1. So let's say that the default value is always 1. This 2 here is known as the frequency, and let's say that by default that is always 1. We are comparing it with this cosine x function. What is minus pi over 2? That is the phase difference. The phase difference of this function is pi over 2. And this is the horizontal, or the vertical rather, shift. And pi over 2 is nothing but the horizontal shift. The default value of the vertical and the horizontal shift being equal to 0. So let's just define that. The default value is 0 and the default value for the vertical shift 2 is 0. If this sounds like Greek and Latin, we'll come back to this and once we draw these graphs, it'll be easier for us to understand. So let's just draw out the amplitude. So let me draw a graph. And this is, let me change the color, having a tough time moving around with the color. So let's come back to a function that we want to draw, that is 2 cosine 2x minus pi over 2. This means that the maximum amplitude, which is between -1 and +1, changes to 2 and +2. So this becomes +2 and this becomes -2. These are the maximum values that this function is going to take. So let's draw that. Our graph is going to be between +2 and -2. That is the maximum amplitude that this graph is going to take. However, we also have a vertical shift which is -3. So this graph is going to move down 3 on the x-axis. So if this was 0 earlier, this would now be -3. So you can say -3 here. You can do a subtract a -3 here and a -3 here. So this becomes -5, this becomes -1, and this becomes -3. Now the graph is shifted to the left by pi over 2, or what you could say is that 2x minus pi over 2, at which value is this going to be equal to 0? That value is going to be x over 4. If you solve for x, if you solve this equation for x, you'll get x is equal to pi over 4. So instead of starting at 0, this graph actually starts at pi over 4. So you can mark your pi over 4. Let's say that this is pi over 2 this entire period. This is pi. So this graph actually starts at pi over 4, which means that this graph will start here and be shifted pi over 4 places to the left. And this is pi over 4, this point here. This point over here is pi over 2. This is pi over 2 plus pi over 4, and this is pi, and this point here at which the graph, this point here is minus pi over 4.